Welcome to our channel. Today under Chemistry Made Easy, we are going to see about the oxidation number and how useful it is to understand the course of a chemical reaction. Oxidation number or the oxidation state of an element. It is an assigned number given by the scientists to understand chemical reactions in a better way. This number is also equal to the number of valence electrons of an element in a compound. This number can have any values positive, negative or 0. This number is used by chemists to keep track of the electrons in a compound and its transfer during chemical reactions. Now, what is the use of this oxidation number? It is used to understand the mechanism of chemical reactions, bond formation, compound formation, and many others. In this chapter, we are going to see the calculation of the oxidation number and how this number is used to solve or balance chemical equations. Now, when we come to this oxidation number, it can be positive, negative or 0. Now, we have two types of compounds in chemistry, ionic compounds and covalent compounds. Ionic compounds by nature are bipolar. There is a positive charge and a negative charge. Covalent compounds on the other hand are formed by the sharing of electrons equally. It is assumed that the bond which is made by a pair of electrons, the electron density is drifted towards one of the atoms, that too which is electronegative. So the element gets the negative charge, the other element gets the positive charge. So this is how the elements are given charges. There are set of 7 rules to be followed in assigning the oxidation numbers. Now let us see how the numbers are assigned. When an element exists by itself, that is, when it is in the uncombined state or in the free state, it is given a value 0. In a neutral compound, when we add the oxidation number of all the ions, it amounts to 0. The oxidation number of an ion is the charge carried by the ion. For halogens, fluorine, chlorine, bromine and iodine, the number assigned is -1. For group 1A metals, lithium, sodium, potassium, rubidium, cesium and francium, the number assigned is +1. For group 2A metals, beryllium, magnesium, calcium, strontium, barium and radium, these alkaline earth metals, the number assigned is +2. Hydrogen has a dual nature. When it exists with a metal, it gets -1. When it exists with a non-metal, it gets +1. For example, hydrochloric acid, HCl. Chlorine is a non-metal. When it exists with a non-metal, it gets a value of +1. Oxygen can exist as oxide and peroxide. When it is oxide, it gets value -2. When it is a peroxide, it is assigned a value of -1. Always metals have a positive number. The non-metals may get a positive or a negative number. When it is a positive number, it is obtained by subtracting 10 from the group number in which it exists in the periodic table. With these rules in mind, we can find the oxidation number of any element in a compound. Let us calculate the oxidation number of a few elements. The first example is iron in ferric chloride. The element for which the oxidation number has to be found is given X. So X plus 3, because it is the chloride, according to the table, chlorine gets a value of -1. So X plus 3 times -1 is equal to, it is given 0 on the right hand side because this is a neutral compound and the sum of all the oxidation numbers of the elements in a neutral compound is 0 according to rule number 2. So X comes to plus 3. The second question, find the oxidation number of copper in cuprous sulfide. It is Cu2S. So we have to take X for copper, and since it is 2, let us take it as 2X. 2X plus, for sulfur it is -2. So 2X plus -2 is 0. 2X is equal to 2. So X is equal to 1. Calculate the oxidation number of manganese in potassium permanganate. So K is first group metal. So 1 plus X plus 4 times -2 for oxygen is equal to 0. So 1 plus X minus 8 is 0. X is equal to 7. Calculate the oxidation number of manganese in MnO4 minus permanganate ion. So X plus 4 times -2, if you see in this particular question, it is -1 on the right hand side. In all the previous compounds it was 0 because those were neutral compounds. Here it is an ion, a charged ion. So it is -1. This -1 is put on the right hand side. So X is equal to 7. Calculate the oxidation number of Sn is tin stannum. Sn in SnCl2 and Sn in SnCl4. If you calculate in this way, X is plus 2 in this and X is plus 4 in this compound. So the same element stannum shows two different oxidation states, plus 2 and plus 4. The lower form, which has an oxidation state of plus 2, ends with the suffix -us, and the one with the higher oxidation state ends with -ic. So stannous and stannic are the two different oxidation states of tin with oxidation numbers 2 and 4 respectively. Calculate the oxidation number of iron, ferrum, in FeCl2 and FeCl3. Here it is plus 2 and here it is plus 3. The lower one is ferrous and the higher one is ferric. To understand a reaction better, the change in oxidation number of the elements while going from the reactant side to the product side is noticed. If there is an increase, it is understood that oxidation has taken place, and if there is a decrease, it is understood that reduction has taken place. Now let us take this example. Zinc reacts with copper sulfate to give zinc sulfate and copper. When we write the oxidation numbers for free metals, it is 0. The value assigned is 0. So zinc here is 0 and copper here is 0. In copper sulfate, copper is plus 2, sulfur is plus 6, oxygen is minus 2. Zinc is plus 2, sulfur is plus 6 and oxygen is minus 2. Now we have to identify the elements which have undergone a change in the oxidation number. In this reaction, let us compare the elements on the reactant side and the product side. Zinc has changed from 0 to plus 2. Copper has changed from plus 2 to 0. Sulfur is plus 6 on the reactant side, plus 6 on the product side, no change. Oxygen minus 2 on the reactant side, minus 2 on the product side, no change. So zinc and copper have undergone a change. Now let us see the magnitude of the change. Zinc has increased from 0 to plus 2. Whenever there is an increase in the oxidation state, the process is oxidation. It is also called the loss of electrons. Let us see copper. Copper has come down from +2 to 0. So there is a decrease in the number. It is reduction or gain of electrons. By understanding the electron transfer within the reactants, we can make out the course of the reaction, and this transfer of electrons, which is nothing but the flow of current, electricity, can be generated from a chemical reaction if we understand the basics of oxidation number.